Oh dear, it looks like Cuthbert is really stuck this time. In previous tutorials, you've edited the scene to help Connie reach Cuthbert. But this time, you'll be editing Connie herself, supercharging her with some new abilities to get past the obstacles in the scene. Bear in mind that this is a complex tutorial in which it's easy to make a mistake. If you do, remember to use the left directional button to undo. Now go into play mode and see how far you can get. Possess Connie with R2 and press the X button to jump. Oops, she can't even get over the first obstacle. So let's start by souping up her jump height. Switch back to edit mode and we'll get started. To change Connie's jump height, all we need to do is tweak her. So hover over her, hold L1 and press the square button to open her tweak menu. This is a puppet tweak menu. As you can see, it's jam-packed with different options. Thankfully, the setting we want is on the first page. All these settings control Connie's overall movement. We could make Connie run super fast or super slow. But nah, that's not going to help her. A nice high jump is what we need. What do we have here? This slider controls Connie's jump height. Hover over it with your imp and hold X to grab it. Move your imp to adjust the slider to around 3 meters. That should be enough to get over that stack of blocks. The Puppet Tweak menu also has some really useful testing controls. Click R3 to start time and Connie will come to life. See what happens now if you hover your imp over the jump height slider. You can preview the jump, so you can get it to the perfect height without having to test it in play mode. Actually, I think you should dial it back to 2.5 meters, or she might overshoot the jump. You can make small adjustments to sliders by using the up and down directional buttons. Hover over the slider and use the down directional button to adjust the setting. Feel free to explore some of the other settings in the menu. If you're not sure what a button or slider does, just hover over it for a few seconds and a more info tip will pop up to explain. You can even adjust the strength of gravity on her jump. Turn it down a bit to make her jump more floaty. When you've got Connie's jump the way you want it, give it a test run in play mode. See how far Connie can get now, then move on to the next step when you're ready to continue. Well, that was pretty cool. Unfortunately, Connie's new jumping skills aren't going to be much use on the next obstacle. And don't even think about making her jump over the top, because that force field will zap her in a second. Instead, let's give Connie the power to crouch. I bet she's always dreamed of it. If you're still in play mode, switch back to edit mode now. Rewind time with L3 to put Connie back at the start. To give her a crouch, we need to scope into her. Puppets are made up of sculptures, connectors and gadgets that are grouped together. Hover over Connie, press and hold L1, then press X to scope in. When you've scoped into a puppet, you can see its inner workings. On Connie's back, there's a microchip gadget. It's called Connie's brain, and it contains all her logic and animations. Let's take a look inside. Hold L1 and press X over it to scope in and open the microchip canvas. There's quite a lot going on in here. The gadget I want you to look at is this one in the bottom right corner with the diamond icon. This is a keyframe gadget. If you've played through the keyframes and timelines tutorial, you'll already know all about these. Keyframes record changes to things in the scene. They store those changes in a gadget, which can be triggered using logic. This keyframe contains a crouching pose for Connie. Select the keyframe with X, and you'll see a preview of how it looks. Those dashed lines over Connie show that she's being changed by the keyframe. Press circle to deselect the keyframe, and she goes back to normal. To be able to activate the crouch keyframe, we need to connect it to Connie's controller sensor. Then you'll be able to make her crouch with a controller button. In the next step, I'll show you how to do exactly that. To activate the crouch, we're going to connect it to Connie's controller sensor. If you've closed her microchip, scope back into her and then scope into the microchip to open it up again. The controller sensor is the large gadget on Connie's microchip. It has a controller icon on it. Open up its tweak menu with L1 and square. Now you have a microchip and a tweak menu open, you may need to arrange them on the screen. Make sure that the controller sensor and its tweak menu stay to the left. This is because they generate signals, and signals flow through gadgets from left to right in Dreams. You can also save the 3D space position of tweak menus and microchips, or pin them to the screen, using the buttons that appear at the top when hovering over the canvas. This will help you keep them tidy while you're editing logic, which is very important as it's easy to make mistakes. Now, let's take a closer look at that controller sensor. Ah, look, controller buttons. Just what we need. All playable characters contain a controller sensor gadget like this one. But the gadget can also be used for any situation where you want to detect button presses. To assign our keyframe to a button, we just need to wire it to the controller sensor. We won't use a circle button as that depossesses Connie, and X makes her jump. So how about the square button to crouch? Make sure you can see the keyframe on the microchip. Move the tweak menu with R2 if you need to. If you hover over the square button in the controller sensor menu, you'll see ports appear on either side of it. They're just like the ports you see on gadgets. Ports on the left are inputs, and ports on the right are outputs. Now, you need to be very precise for the next part, as it's easy to make a mistake. Carefully hover your imp over the output port of the square button, and press X to create a wire. Stretch that wire over to the keyframe, and connect it to the power port on the bottom of the gadget with X. If at any time you make a mistake, just undo it using the left directional button. Once your crouch move is all wired up, close the controller sensor tweak menu. Hover over it, hold L1, then press circle to close. Now try out Connie's new crouch in play mode. See if she can make it under the second obstacle. When you're ready to continue, go back to edit mode. Rewind time with L3 and start the next step. Right, we're on to the final obstacle. There's no way around it, but it looks destructible. So we're going to make a slam attack for Connie so that she can smash through it. We'll start by recording a pose for the slam. We can do this using a keyframe. Scope back into Connie and open up her microchip if it isn't already open. If you've played my keyframes and timelines tutorial, you'll have a bit of a head start on this next part. Go to the Assembly menu and open the Animate menu. Select the keyframe with X. You'll now have a keyframe gadget on your imp. Stamp it somewhere in the scene with R2 or X. The keyframe records changes you make to objects and settings in the scene. It starts recording as soon as you stamp it. You can tell it's recording because your imp will change shape and color. Now that we're recording, grab Connie's upper body with R2 and drag it gently down to the floor. Because we're scoped into her, we can move her body parts individually to create a pose. If we weren't scoped in, we'd move Connie's whole body. Notice that her knees automatically bend. Make sure her cone is all the way down to the floor so that you can't see her legs. Keyframes can record changes to anything, even tweak menu settings. So, just for visual flair, let's also make her glow. Hover over Connie's cone, hold L1 and press square to open its tweak menu. Because we're scoped in, this opens the tweak menu for the sculpture itself, rather than the puppet. All the settings on this page change the way Connie's cone looks. Look for the glow slider on the first page. Its icon is a sun. Raise the glow up to about 40%. Once you've set the glow, select Stop Recording in the context menu to store the changes to the keyframe. You can close the tweak menu now too. Just hover over it, hold L1 and press circle. Select the keyframe gadget with X to preview what's been recorded. Looks good. Deselect the keyframe by pressing circle. In the next step, we'll continue building Connie's slam attack. The next step is to place our new Connie animation into a timeline. Using a timeline will let us time the animations and effects of the slam attack. Go to the Assembly menu and back to the Animate menu. Select the timeline with X. Hover over Connie's microchip and stamp a timeline above the crouch keyframe. Now let's open the timeline canvas with L1 and X. The slam attack should be a really quick animation. So adjust the canvas so it's only 1 second long. Any longer and it won't feel snappy enough. Hover over the edge of the timeline canvas so that a white line appears along it. You'll also see a white double-ended arrow appear next to the edge by your imp. When you see this, grab the edge of the canvas with X. Move your imp to shorten the timeline to 1 second. Make sure you don't select the trim button by mistake. It's a square button by the numbers at the top of the timeline. It has a black arrow on it. The timeline duration is now correct, but the space is very small. So let's zoom in a bit. Hover your imp over the timeline canvas, hold L1 and press the right directional button to zoom in. This will keep the timeline duration to 1 second long, but stretch the space so that you can fit more detail into it. If you need to zoom out, just hold L1 and press the left directional button. Now let's put our slam attack keyframe onto the timeline. Grab the keyframe with R2 and place it at the start of the timeline canvas. Make sure you've got the slam keyframe and not the crouch one. The gadget automatically snaps to the surface of the canvas. The keyframe is only a fraction of a second long at the moment, but we need it to fill the length of the timeline. So hover over the keyframe and hold the up directional button to scale it. Make it the same length as the timeline. Now we want to wire the timeline up to a button press, just like we did with the crouch. Move the timeline canvas so that you can see the controller sensor and the timeline gadget. Open the controller sensor tweak menu with L1 and square. I'm going to use L1 as the slam attack button. Hover over the output port of the L1 button and press X to create a wire. Stretch the wire down to the timeline gadget and connect it to the power port on the bottom. You can now use the L1 button to perform Connie's slam attack. Give it a try in play mode. At the moment, it's just an animation, so it's not going to do anything to the blocks. But in the next step, I'll show you how to add some force to it. When you're ready to continue, return to edit mode, rewind time, and start the next step. The slam attack animation is all set up, but it's not doing much besides looking cool, so we need to add a gadget to our timeline that will emit a force when Connie slams the ground. The gadget we're going to use for this is the force applier. Go to the assembly menu and open the gadgets menu. Find the movers and output menu and open it with X. The icon for the force applier looks like a gust of wind. Select it with X to equip it to your imp. I hope you've still got the timeline open. If not, open it with L1 and X. Stamp the force applier onto the timeline canvas below the keyframe. Press circle to unequip the force applier from your imp. The force applier isn't very strong by default, so we'll need to tweak it. To open its tweak menu, hover over the gadget, hold L1 and press square. At the top of the tweak menu is the force strength slider. Its icon is a beefy arm. Drag it all the way up to 100% using your imp. That will ensure the force emitted will overcome the gravity in the scene and the friction between the blocks. Next, increase the force speed to 10 meters per second. That will give the slam attack some punch. If you take a look at Connie, you'll see a green zone around her. Anything in this zone will be affected by the force applier. At the moment, the zone isn't much bigger than Connie. Hover your imp over the zone and arrow gizmos will appear. Grab them with R2 and move your imp to change the size of the zone. Or you can scale the zone more precisely in the force applier tweak menu. Go to the tab called Zone Size. Grab the zone size slider with X and set it to about 3.5 meters. Okay, let's test out Connie's new powers. Switch over to play mode. Possess Connie and give her new slam attack a try. Oops! Looks like it's more power than Connie can handle. The force applier is pushing her off the platform. Switch back to edit mode and rewind time. In the final step, I'll show you how to tweak the force applier so that it only affects the objects we want it to. To prevent the force applier from pushing Connie off the platforms, we're going to use labels. Labels can be given to any object in the scene, and gadgets like the force applier can detect them. In the Force Applier Tweak menu, go to the Labels tab. By default, it will detect all labels. There are labels for all sorts of objects: foes, scenery, targets. The friend label is used for playable characters like Connie or friendly characters like Cuthbert. So if we deselect it, the Force Applier will no longer affect Connie. Hover over the Friend button and press X to deselect it. It's the button with the heart icon. Now Connie should be able to blast through the blocks without firing herself off into space. Use her new skills to pass all the obstacles. And you can use your new skills to create some characters for your scenes. When you've successfully rescued Cuthbert, go through the door to finish this tutorial.
Connie and Cuthbert are at the Dreamiverse racetrack. They're testing out a new Cuthbot model of my design. Looks like Connie's already got the hang of it. Give us some welly, Cuthbert. Oh, maybe not on second thought. Join me over in edit mode, and I'll show you how to make a vehicle of your own. To get this Cuthbot operational, you'll need to add a few gadgets. The first step to making something controllable is to add a controller sensor. The controller sensor is mostly used in puppets, but it can be used to control anything. This Cuthbot is made from sculptures and connectors that are grouped together, so we need to scope into the group before we can start editing it. Hover your imp over Cuthbot, hold L1 and press X. On the front of Cuthbot's chassis, you'll find a microchip. This is where we'll put all the gubbins to get Cuthbot moving. Scope into the microchip with L1 and X. It looks like we've got some work to do. There's only a health manager set up. The microchip is surface snapped to Cuthbot, so all the gadgets inside it will act like they're surface snapped too. A useful feature of microchips is that once you've opened them, they will stay open even if you scope out of the group they're in. However, if you close the microchip, you'll need to scope back into Cuthbot to open it up again. Start the next step and we'll start building Cuthbot's controls. First on the agenda is to add a controller sensor. Then we'll be able to possess Cuthbot with the imp. Go to the assembly menu and select Gadgets. The controller sensor is found in Sensors and Input. Its icon is a controller and some cogs. Select it with X and stamp one on the left side of the microchip canvas, just to the right of the Health Manager. The controller sensor will be powering all the other gadgets, and in Dreams, signals run from left to right. Since the Health Manager's right here, let's hook that up first. When the Health Manager has no health, the controller sensor should get a signal to die. It sounds rather grisly, but it just means Cuthbot will be able to respawn if you drive off the track. Position your view so you can see the ports on the Health Manager and let's dig a little deeper into the controller sensor. Open the controller sensor's tweak menu using L1 and the square button. Head to the Important Properties page. All these settings are to do with your imp, as you could probably tell from my hilarious pun. At the bottom, there's some options for changing the possession visual. This is how your imp will appear when it's possessing this controller sensor. Cuthbot has a little cockpit for the imp on top of its chassis. So change the possession visual to visible, body on target. A round gizmo with a face has appeared on Cuthbot. Move the tweak menu to the side with R2 if it's in the way. This gizmo shows where the imp will appear and in which direction it will face when Cuthbot is possessed. Before we move it, go to the Assembly menu and select Guides. Switch on Grid Snap and set the size to half. This will keep the imp gizmo oriented properly. Grab the gizmo with R2 and line it up in the cockpit on top of Cuthbot. Now we have a driver. Let's see how it looks. Close the tweak menu with L1 and circle, then switch over to play mode in the options menu. Possess Cuthbot with R2. Hooray! You've given Cuthbot life. But this is just the start. When you're ready to add more, go back to edit mode, rewind with L3, and start the next step. When you were in play mode, you might have noticed that Cuthbot's body tilted over. That's because it's movable, and when objects are made movable, they're affected by the physical forces in the scene. So before we get Cuthbot moving, we need to add some stabilization. A gyroscope is the perfect gadget for this. It's used to keep objects upright. Go to the Assembly menu and select Gadgets. Close the Sensors and Input menu with Circle, then open Movers and Output. Look for the gyroscope icon in the menu. Select it with X and stamp one onto the microchip canvas. The gyroscope doesn't need to be connected to any other gadgets. It just has to be attached to the object you want it to stabilize. Unequip the gadget by pressing the circle button. Now open the gyroscope tweak menu. In the tweak menu, look for the slider with the beefy arm icon. This is the gyroscope's strength. The stronger the gyroscope is, the more easily it'll overcome the forces in the scene. Drag it all the way up to 100%. That'll keep Cuthbot perfectly balanced. To keep Cuthbot upright, the gyroscope needs to know which direction is up. That's what this arrow gizmo on Cuthbot is for. By grabbing and moving the arrow, you can change the orientation of the gyroscope. It looks perfect as it is, so close the tweak menu, then click R3 to check the gyroscope is working. Solid as a rock. When you're ready to get motoring, rewind with L3 and Right then, let's get Cuthbot moving. For that, we'll need a mover. If you've closed Cuthbot's microchip, scope back in and open it up again with L1 and X. Go to the Assembly menu, then select Gadgets. In the Movers and Output menu, see if you can find the mover. Its icon is a box and an arrow. Select it with X. Stamp a mover on the right side of the microchip, then unequip the gadget with Circle. As the microchip is surface snapped to Cuthbot, anything on its canvas will also behave like it's surface snapped. This also means that moving the microchip will affect the position and behaviour of all the gadgets inside, so make sure it's positioned where you want it before tweaking the mover. Now select the mover with X. Selecting a gadget, or opening its tweak menu, reveals its gizmos. If any other gadgets have their gizmos visible, just close their tweak menus or deselect them with X. The mover gizmo shows which direction it defines as forwards. So at the moment, the mover's gizmo is pointing in the wrong direction for Cuthbot. Before moving the gizmo, make sure you still have Grid Snap activated in the Guides menu. Then grab the mover's arrow gizmo and point it in the direction you want Cuthbot to move. You can use gizmos without Grid Snap, but it's tricky to get them lined up exactly. Now click R3 and Cuthbot should move in the direction of the arrow. I don't think we'll be setting any Dreamiverse speed records, but we're on the right track. Click L3 to rewind the scene, then start the next step when you're ready. Now we've got Cuthbot moving, let's see how we can control it. We'll start by connecting the mover to the controller sensor. The port we need isn't available on the outside of the gadget, so open up the controller sensor's tweak menu with L1 and square. By default, tweak menus are pinned to the screen. But if you want to arrange them in the scene space, just deselect the Pin to Screen option at the top of the tweak menu. You can also save the position of tweak menus so they always open in the same place. Just select the anchor icon at the top of the tweak menu to save its position. We're going to use the R2 button to make Cuthbot move. On the first page of the controller sensor tweak menu, you'll find all the controller buttons. Create a wire from the R2 output port of the controller sensor using R2 or X. Extend the wire across to the mover. Connect it to the forward speed input. Now close the controller sensor tweak menu. Before we try it out, let's give the mover a bit more juice, as it was painfully slow before. We'll take care of that in the next step. Right. Let's see if we can give Cuthbot a bit more oomph. Open the mover's tweak menu and use X to increase the forward speed slider. "50 meters per second should be a bit more lively. We should also set the mover to work in local space. This means that the direction of the mover will move with Cuthbot. This will be super important when we add steering to Cuthbot's logic. At the moment, the mover is working in scene space. When set up like this, the mover will go in the direction of the arrow, no matter what direction Cuthbot is facing. This would make it impossible for Cuthbot to turn. Select the button with X to switch to local space. Now, if you grab and move the arrow gizmo, you'll see the axes move with it. Make sure the arrow gizmo is pointing forward. If you've still got Grid Snap turned on, it'll snap exactly into place. Now when Cuthbot turns, the direction of the mover will turn too. Now close the tweak menu, then switch over to play mode and give it a go. Now that we have a forward gear, we need to set up reverse. We can do this using the same mover gadget. But if we want to use a different button for reverse, we'll need to use a combiner. Go to the Gadgets menu and open Logic and Processing. The icon for the combiner is two lines converging into an arrow. Stamp one onto the microchip canvas between the controller sensor and the mover. Unequip the combiner with the circle button. An important thing to know about wires is that they can carry more than one signal. Wires carrying multiple signals are called fat wires. The combiner can make fat wires by taking signals from multiple inputs and combining them into one. Take a look at the inputs on the combiner. This combiner will combine a positive signal and a negative one. By wiring the controller sensor through the combiner, we can use R2 for acceleration and L2 for deceleration and reversing. Hover your imp over the wire going into the mover so that it highlights. Grab it with R2 to unplug it, then connect the wire to the positive input port of the combiner instead. If the controller sensor tweak menu isn't already open it up now with L1 and square. For reverse, create a wire from the L2 output of the controller sensor. Extend the wire over to the combiner and connect it to the negative input port. Finally, select the output port of the combiner with R2 or X and connect a wire to the forward speed input of the mover. So now the wire going into the mover is carrying a positive signal to accelerate with R2 and a negative signal to brake and reverse with L2. Don't just take my word for it though. Give it a try in play mode. Now we're really motoring. All we need now is the ability to steer Cuthbot. We'll get cracking with that in the next step. We'll need some steering if Cuthbot's going to get round these corners. As Cuthbot only has 2 wheels, we can keep things simple and use a rotator to steer. Go to the Assembly menu and navigate back to Movers and Outputs. Close any open submenus with circle if they're in the way. The icon for the rotator is a cube with a dotted line around it. Select it with X and stamp one above the mover. Then unequip the gadget with circle. Open up the rotator's tweak menu so we can make sure that its gizmo is oriented correctly. If any other gadgets have their gizmos in the way, close their tweak menus or deselect them with X. The rotator gizmo shows the rotation axis and speed. At the moment the plane of rotation is aligned vertically. That'll be no use for steering. Grab the long handle of the gizmo with R2 and move it up so the rotation is in the horizontal plane. Make sure you're using Grid Snap, otherwise it'll be very difficult to align it accurately. The moving line in the gizmo shows the rotation is anti-clockwise. Click R3 to test it. The rotator might need a bit more strength. Robots are heavy things. In the tweak menu, try increasing the rotation strength. It's the slider with the muscly arm. That's done the trick. About 90% is strong enough. Rewind time with L3. Close the tweak menu with L1 and circle. In the next step, we'll connect the rotator to the controller sensor. We're going to steer Cuffbot with the left stick. Open the controller sensor's tweak menu with L1 and square, then go to the third page. You'll find left and right stick outputs on the second page too, but the ones on the third page are local outputs. Local just means that left and right is defined in relation to the controller sensor. So just like with local space on the mover, using the local outputs means left on the stick will be Cuffbot's left rather than left from the camera's perspective. Remember, you can always find out more info about buttons just by hovering your imp over them for a few seconds. The left stick output doesn't just send signals for left and right though, it also goes up and down. But we only need left and right for steering, so we need to split the signal. Go to the assembly menu and back to logic and processing. Look for the splitter. The icon is a line splitting into two arrows. Select it with X and stamp one on the microchip canvas, between the controller sensor and the rotator. The splitter does the opposite of what the combiner does. It splits fat wires into their individual signals. Now select the left stick local output of the controller sensor with R2 or X to create a wire. Connect it to the splitter's input port. The splitter has now split the left stick wire into two parts, X and Y. Or left, right and up, down, as they're more commonly known. The X output, left, right, is what we need, so create a wire with X or R2 and connect it up to the rotator's rotation speed input. Time for a test drive. Switch over to play mode and give Cuffbot a go. Cuffbot's steering's not very responsive. And it seems we've got left and right back to front. How can that be? Looks like we've got some more work to do. While you were testing your Cuffbot, I quickly tidied up my logic. It never hurts to keep your logic neat and tidy, but I'm not here to judge. Tidy logic is much easier to follow, and also easier to fix when it goes wrong. Speaking of which, Cuffbot's steering needs a bit of tweaking. At the moment, it's very heavy, and left and right are the wrong way round. The good news is, we can fix both these problems just by tweaking the rotator speed. The rotator has plenty of power, but it just doesn't turn enough, so increasing the speed should help. Grab the rotation speed slider with X and drag it to the left. But you said increase the speed, I hear you say. Indeed I did, but to get left and right the right way round, we also need to reverse the direction of the rotator. Once you've dragged the slider down to 0, it'll stop. But if you let go of X and grab the slider again, you'll be able to drag it into negative values. Set the rotation speed to about -700 meters per second. The speed slider will snap back to 0 when you let go of it, as we're setting the maximum speed, not the current speed. That should do it. Cuffbot is now ready for the track. Before we play the scene, let's just quickly review the logic. The controller sensor generates the signals that power the rest of the logic. the fat wire from the left stick local output is split into its X and Y signals. Then the X is used to change the rotation speed of the rotator. The R2 and L2 buttons are combined into a fat wire, carrying a positive and a negative signal. The fat wire powers the forward speed of the mover. The positive signal accelerates and the negative decelerates. This simple logic is all you need to create the foundation for a vehicle. As you learn more about logic, you can expand on it to create more sophisticated handling. Time to take Cuffbot for a spin. Switch over to play mode and see if you can complete the course. If your movement or steering isn't working the way you expected, switch back to edit mode and take a look at the tweak menus for the mover and rotator. Make sure the gizmos are correctly oriented and check that the mover is using local